Good morning, ladies and gentlemen. Thank you all for joining. We have an audience today from Guatemala to Ontario and from Oklahoma to New Jersey, so just about coast to coast. We have North America pretty well covered, and we really appreciate everyone's time and attention. We know that your time is valuable, and we hope that today's webinar contributes to your understanding of this LED general white light technology. I want to share with you a brief prelim before we begin and tell you about MaxLite's experience getting into general lighting with LED technology. Of course, we had exit signs and exit sign retrofits and specialty products that required colored lamps, and we had used LEDs before. But white LED, when it first made its way onto the scene and had pretty good efficacy that made sense for using in general lighting, the lifetimes was very difficult. Although our product development team and management had over 100 years combined experience in lighting, we knew exactly how to move forward, but we did debate on how to state the life of the products. At the time, the information seemed, very, very optimistic, and, we're a relatively conservative company. So what we did was we settled with where the big three were, the big guys, and what they were doing for the majority of their LED luminaires at the time was 50,000 hours with a depreciation of about 30% at 50,000 hours, which is translated into the term L70, 50,000 hours. For the bulbs, they were between 15 and 35,000 hours, and again, these were stated at 30% depreciation, so it was L70, 15,000 hours for like MR lamps, and L70, 35,000 hours for A bulbs and that type, and MaxLite followed suit. So here it is now, almost 10 years later. There is more data and information than ever, and I bet you think that we can tell you the life of that LED luminaire right down to the hour or the minute. But in fact, it is not the case. As more information comes out, it is proven to be just as difficult, and that's what we're doing today, is to share with you what we've learned and how we state the life of our LED products and what the industry standards are. The baseline, let's start with how is the life of light products, light sources measured before LED. And it's basically, the average rated life was basically the 50% failure point. In other words, if you lit up 100 lamps, when 50% of them have failed, you round off the hour, and that's the stated life. So you have about 50% failure rate at 1,000 hours. And I've gotten those calls where they failed at 50 hours or 400 hours. With CFLs, they are rated for, screw-in CFLs are rated for about 10 to 12,000 hours, which means half of them will have failed in that life. Of course, you get the phone call when it fails at 6,000 when it's rated for 10, but hardly any of us get the phone call when it lasted 14 or 18,000 hours when it's rated for 10. Typical light sources, incandescent is pushing up to about 2,000 hours at a 50% failure point. Fluorescent, linear fluorescent is up pushing 40,000 hours, HID over 20,000 hours. The different types of compact fluorescents, the plug-in pin base are 10 to 20, the screw-in 10 to 12. Halogen lamps are even up to about 4,000 hours in rated life. But with LED, it's not so simple, because with these other light sources, they just fail eventually over time, where LED just continues to diminish in light level. An outright failure for LED take quite some time. It can be actually in the hundreds of thousands of hours, but the majority of that time would not be useful. So how do we measure a useful life for LED products? Well, we need certain information. We need LM80 data, we need in situ test data, we need LM79 data, and we need to understand what L70 is. So let's start there. L70 is the point in which the light over lifetime has depreciated by 30%. So you can have L70. I've heard of a major retailer for their outdoor lighting, they've gone with an L60 lifetime. So they've made a decision that when the luminaires for their outdoor lighting depreciates by 40%, that's when they're going to change their fixtures out. So the standard for the industry is 30% depreciation, also known as L70. L79 data is IES-approved method for the electrical and photometric test of LED lighting devices. This procedure specifies the procedures for measuring total luminous flux, power, efficacy, amongst other things. The LM80 data is also a test method, an IES-approved test method for measuring the depreciation of LED light sources, and it's related to the effective, useful life of the product. One could debate, is that 30%, 40%, 50%, but should not debate on how we arrive at those numbers. Now, another piece of information that's required at this point is an in situ report. The in situ report is a test report that shows the temperature of the LED chip within the fixture itself. The in situ report must be issued by a qualified third-party laboratory, as the same for the LM79 and the LM80 data. Now, once you've got your goal set up for your depreciation point, and let's say L70 going forward, you've got your LM79, your LM80, your in situ reports. You're going to take all of this information and you're going to plug it into the new IES recommended for measuring the projected lifetime or depreciation of LEDs, and that is a TM21 Excel spreadsheet. So you're going to plug all of that information into the TM21 calculator. Once the data is all plugged in, this spreadsheet can extrapolate the point in hours in which the fixture will have degraded by a certain lumen output. And L70, once again, is considered the benchmark. So this is what it takes to actually measure LED luminaires in the cutting-edge, modern way. Now, I want to share with you one of those LM80 reports, or a section of an LM80 report. This happens to be a Philips LumaLED report. Now, notice the blue highlights along the red curve, and what you'll see there are those are the actual test measurements in hours. Now, the IES doesn't allow you to extrapolate more than 6 times the test data that you can demonstrate, and no test data is accepted with less than 6,000 hours. So you need a minimum of 6,000 hour test data, and you cannot extrapolate that beyond 6 times. So in this particular case, what we're looking at is a test time, looks like at about L90 at about 50 or 55,000 hours. It shows an L70 point, and again, this is beyond the 6 times, but it shows an L70 point at about 150,000 hours. Now, folks, this is what I wanted to share with you, is that the data is in, and, well, it is proving to be much better than those conservative members of the industry. The good news is that we are beating every projection that we had set out for ourselves, and it looks like L70, 50,000 hours, is an ultra-conservative measurement. It looks like it's going to be well beyond that. Now, quickly, let's just take a quick look at a typical lumen maintenance curve report. You see there that if other light sources were held to the same L70 standard of LED, metal halide would be considered L70 at about 5,000 or 6,000 hours. High-pressure sodium would be L70 at about 15,000 hours. Fluorescent holds up pretty good and has an L70 that can be beyond 20,000 hours. Induction lamps, considered some of the longest life lighting products in the industry, rated at 100,000 hours, but if it was held to an L70 standard, it would be closer to 60 to 80,000 hours. And we've been showing high-power LEDs at about 50,000 L70 hours. This is a typical chart. I'm going to show you a modern chart. We're looking at L70 numbers that are out beyond 90,000 hours, utilizing the latest methods for measuring lifetimes and lumen depreciation for LED luminaires. And remember, we're still at the beginning of our industry. We've got a long way to go. We have been focusing as an industry on the lumen output of LEDs. When would they reach a point where it makes economic sense to use these? And the efficacies, when they started exceeding 60, 65, 70 lumens per watt, is when major manufacturers such as MaxLite started really putting their R&D behind developing products. Today, we're over 90, 100 delivered lumens per watt, and is one of the highest efficacy light sources that we have today. Now the lifetimes are going to continue to go out because the thermal limits for these products are going higher and higher. The lifetimes are going out further and further. And if you haven't noticed, also the CRI, the color rendering index for these products, are also going higher and higher, and there's less of a premium for higher CRIs. So even though we've been focused on lumen output of high-power LEDs, there's so much going on there, and it's improving in just about every measurable way. I showed you some Philips data a little earlier. Let's review some Cree data here. This is a 40,000-hour measurement, the ambient temperature at 25 C, the junction temperature of the LEDs at 65 C. And, you know, temperature is a huge part of the formula, and we'll discuss that a little more in a moment. But let's take a look at this at the 25C ambient, 65C junction temperature, which is a typical climate-controlled environment with a well-built product. These are the type of temperatures that you would expect. Notice at the first 6,000 hours, there was reverse degradation. In other words, the lumen output actually increased the first 5,000 or 6,000 hours. This is typical in a good design. It took another 1,000 or 2 hours to come back to the 100% initial point. And let's just jump all the way out to 40,000 hours. We're looking at depreciations of about 3%, maybe 4%. Again, this is Celsius, that's right. It's about 70 Fahrenheit ambient, 25 Celsius ambient. So this is the good news. Early on we said, well, how do we know they're going to last 40, 50, 70, 100,000 hours? They haven't been out there that long. Well, actually, they have been out there that long now. This is actual 40,000-hour data, and there's lots of data that exceeds this. I've seen 70 and 80,000-hour data. So not to be redundant, but the good news is we are exceeding all of our expectations. Now, let's talk about how temperature impacts the TM21 results, and that's important for us to understand that, we have to expose these luminaires to the proper application. We can't expect the same performance in a greenhouse in the desert that we would expect in a office environment indoors or a typical parking lot outdoors. So this particular data, what we're showing is the same set of chips and the L70 point, how it's affected at different temperatures. So this data here runs out at about 38,000 hours. And at 55 degrees C, we're looking at, probably, if we extrapolate these lines out, we're looking at 70 or 80,000 L70 hours. But at 70 C, it's much steeper, and we'll probably hit right at that 50,000 L70. And in higher temperature applications, like 85C, we're looking at L70 at 40,000 hours. Now, fortunately, we don't have a lot of applications at 85C, but there are some out there, and this is the type of life that you would expect. But in temperature-controlled environments and in outdoor applications where the lights are on typically in the evening hours with controls, turning them on and off, you should expect extraordinary lives from these products. Now, let's talk about drivers, because this obviously is the weak link. I've been stressing how the lumen depreciation of LEDs is much less than what we had anticipated. Even the very conservative members of the industry did not expect this type of very slow depreciation. So the weak links are the driver and, in some cases, the controls, which is not usually what we expect. Usually we're expecting it to be the lamp. So let's talk about driver reliability, and let's all keep in mind that this is actually, an LED driver is a power supply. We, as an industry, know how to make fantastic power supplies that can last 80,000 plus hours. We also know how to make very inexpensive power supplies that would be ridiculous to match up with LEDs because of the life expectancy we expect out of an LED product. So, there's good drivers and there's bad drivers. I would say, in my own humble opinion, that the driver is the weak link for most LED luminaires, and you get what you pay for. If you have a driver that's running at a specific set of standards or specifications, has a set of features, and it costs $40, and you have the same set of specifications on another driver that costs $100, I assure you, you're going to get better performance out of the more expensive one. Not that cost always translates into quality, but that's where you go back to who made it and understanding what it is you're buying. And my best advice is to get products that have integral drivers. This way, we've been in the lighting industry a long time. We all know the situation where we have a large job with huge numbers of linear fluorescents and ballasts. And from time to time, there are problems. And what happens is the ballast people say, it's the lamp. Our ballasts are running fine. We've checked them out. They look good. And the lamp people say, it's the ballasts. And, there's a lot of finger pointing going on. When you use a product such as what MaxLite makes, it's a MaxLite driver with a MaxLite light array. And if MaxLite, and from time to time we do, reach out to some of the other major driver manufacturers, your warranty is still all under us and through us. So I would always recommend getting your fixture with an integrated driver. If you're outsourcing your light source separate from your driver, you could potentially run into compatibility issues and warranty issues. I've had a couple of questions here. The LED chips, Caesar, are absolutely affected by temperature, and the driver is as well. You know, there's certain components on a driver that should be kept under a maximum temperature. Usually these temperatures are pretty high, 85, 90 C. 90 C would be the highest case temperature that's allowed for UL and other safety agencies. But what we're showing you, the data we're showing you today, is that at temperatures of 70 and 85 C, and even temperatures I showed you with the Cree data, you can see that we're getting extraordinary lifetime. So absolutely, temperature affects the lifetime and particularly the lumen depreciation of the chips. But what I'm telling you is that we're holding up better at higher temperatures than we had ever thought that we would. Now, again, I really appreciate everybody's time and attention. I hope that you found this information valuable. We want to remind you that we do have the MaxLite Utility Rebate Finder for our domestic clients that has close to 300 utilities that shows not just whether they're all rebatable or not, but also how much the rebate is, and it allows you to download the rebate form for all of the MaxLite products that pertain to your individual state and utility. We've got the ROI calculator, which will help you to calculate the return on your investment with all of the MaxLite products, and it's been upgraded to have a more extensive drop-down menu, which allows you to choose and get through the calculator in record time. We also have the university.maxlite.com, absolutely free, earn your lighting degree, recommended to your employees, to your clients for their employees. It's a true university, like any other online university, except that it's exclusively about lighting, it's non-commercial, and it's completely free. And last but not least, I do want to remind you all that MaxLite provides a custom product and training sessions for you. If you would like a lunch and learn, breakfast and learn, on-site or online, we can run through a training for your specific group, whether it be on specific MaxLite product or a broad overview of our product, or maybe a total non-commercial webinar focusing on LED technology or general lighting. Whatever it is that you think would benefit you, we are here to aid you. So feel free to call on us if you think that this will help you in your sales. Again, thank you so much for spending your time with us. I hope that this 20 or 25 minutes has proven to be valuable for you. This will go up online at MaxLite.com and at YouTube. If you think that your friends or colleagues would benefit from going through this presentation, you'll be able to send them a link very soon. Look for that link in your email box soon. Thanks again.